Greetings everyone. My name is Bagner Decruzz Juilis, representing the research for the UMS-CoFA2020. The research title is The Modeling of the Water Quality Trends for Predicting Coastal Recreational Suitability Using Deep Learning Approach, the paper ID FKI20. So today's presentation will be covered the introduction, the background, the proposed approach, and also the conclusion and the future work for this research. So we start off with it in the introduction. So basically, coastal recreational area denoted as one of the peer source of income in any state or national's GDP and well known as the tourism attraction, especially in Sabah. Coastal recreational area not just contribute to the public attraction, but also to boost the tourism attraction from public and overseas tourism, meaning to say that the coastal recreational do need some adjustment in order to fit in the best urbanization management for safety and also the tourism attraction. As time goes by, such rapid development of economy and urbanization, not just at the coastal area, but also at that particular area, including maybe construction, manufacturing, and so forth, do impact the coastal area, especially the water quality at the coastal recreational area. So as the issue addressed, we need to understand the issue highlighted and also the trends of the water quality for short and long terms recreational usage. So in this research, deep learning is highlighted as the main approach in order to determine water quality. So take a look in example of the recent research, as you can see in the diagram, conducted by Simeon, where they demonstrated the predicting of pH and redox condition mapping using machine learning approach. So similar to the research focus in terms of the water quality issue, the understanding of the issue and thus propose a proper solution is essential in order to overcome the issue statistically and precisely proven by time series analysis. But the main question is that what are the deep learning algorithms for predicting the quality trends, and how can a hybrid prediction system be designed for coastal recreational suitability? So the question will be answered by understanding the water quality aspect at first. Over the years, coastal water was habitually exposed to the anthropogenic and industrial pollution that lead to the negative consequence of the public health and recreational activities. Thus, water quality notably is an assessment of sanitary and microbial water quality collectively. The end results of the assessment should give a proper clarification about the water quality around that investigated beaches in order to inform the public, provide on-site guidance, and also the information to the public relative to the safety aspects, assist and promote effectively recreational management, and formulate regulatory compliance. In recent time, it is difficult to detect from a routine surveillance system, which we will talk about that in the next slide, about the conventional model. The controllable and uncontrollable microorganism or pathogen may cause infection disease depending on the specific pathogen's form. Also, the types of the pathogen, the recreational water also influence the water quality, which is fascinating to observe too. So as you can see in the diagram established by WHO, shows that the classification metrics of the water quality assessment as the baseline for getting water quality from the best to the worst quality. So moving on to the upon to the response of the assessment and monitoring of the water, there are few models that have been established and researched by previous scholars via the conventional mechanism model, including Mike, Basins, and FDC model. But due to the lacking of the data processing outcome for the mechanism model, non-mechanism model were established, such as the moving average MA and also the ARIMA model, which is the regressive integrated moving average model. And the focus of the time series is always the main concern in this research, as in particular, and thus few adjustments been made from the non-mechanism model, such as the likes of HDFNN and also the SVR model. So the realization in terms of the lacking of the long-term dependence and the trends of water quality and managing complexity of the water quality parameters is highlighted based on the mentioned models, and thus deep learning approach comes into the pinpoint in order to generate more concise and reliable data outcome. So the proposed method, especially the deep learning method, contribute to the parameters of water quality, temperature, pH value, dissolved oxygen turbidity, chloride, fecal bacteria trigger level, predictive analysis of water quality continuously, time series analysis, extended analysis in a deep learning method of DNN, RNN, and also LSTM, and last but not least, performance analysis of deep learning method using F-score metrics. So digging inside in the deep learning, as you can see that deep learning is the act of the new network of neurons to link between each other, run specific function for activation function, and map the inputs to an output significantly. So the existence of the linear and nonlinear relationship between the input and output is coherent efficiently. So inside the deep learning, we have DNN, deep neuron network, RNN, and also the LSTM. So these three the main components inside the deep learning is very essential in order to prove its approach, and also it prove its effectivity inside the context of time lapse or time series analysis of the water quality trends for the long terms and short and long term usage. So the proposed solution here, as you can show in the diagram, we adapted from the research from Hageni, and we improvised for the sake of this research direction. So the proposed model of DNN, RNN, and LSTM via F-score metrics. So each of the deep learning models will undergo its function accordingly, and the implementation of F-score metric based on the parameters investigated, as mentioned previously, the water quality parameters from each DNN, RNN, and LSTM respectively. So F-score metric accuracy will be tested and formulated based on the formula, as you can see the three formulas there. So a good, perfect, and F1 score is one that explains that there are low false positive and low false negative. So the reason why we use F-score metric is that the models contribute to 98% precision with F-score metric according to the research by Vakili in 2020. So as the conclusion, the concern about the water quality assessment via real-time data analysis issue that been raised. So DNN, RNN, and LSTM have shown great potential in the water quality research based on the previous study conducted. So deep learning via F-score metric as the performance evaluation. So the future work for this research will be in regards to the developing the prediction model using Python, integrated into the full-scale monitoring system for the sake of the cost of recreational suitability prototype system, and last but not least, the design system will be embedded with the IoT applications. So this is the reference for this research, and thank you.